Hello dear students, welcome to Konar classes. In this session, we are going to discuss how to form a differential equation whose general solution is given. Okay, so before we start, forming differential equation whose general solution is given, let us start with a curve. Okay, a specific curve, and I'm going to write it down here. Okay. And I suggest you, dear students, so you also open your notebook and do along with me. Okay, as you proceed, you can pause the video, do your task, and then proceed further. In that way, you will have a fantastic learning. Okay, so let us take this particular curve. X square plus y square plus 2x minus 4y plus 4 equal to 0. As you see, dear students, this is a equation of a circle. Okay, and what we can do is that we can evaluate further to find that what type of circle is it, means what is the coordinate of the center and what is the radius of this circle. To perform this thing, we can do quickly. X square plus 2 into x into 1 plus 1 square. So this is one part, plus y square minus 2 into y into 2 plus 2 square. So what we get, 1 square is 1, 2 square is 4, 5. So here I will write 1 in the right hand side, so it makes complete. Okay, so this implies what, dear students? So this implies x plus 1 complete whole square plus y minus 2 complete whole square is equal to 1 square. Okay, so that means what, dear students? So this is a circle, okay, whose center is at the point minus 1 comma 2 and having radius 1 unit. Okay, so now, dear students, what we are going to do, we are going to form a differential equation representing this particular solution. It's a particular curve. It is not a general solution, by the way. We will come to general solution after a few minutes. So how to proceed further? So we are going to differentiate this. Okay, so if we differentiate, what we are going to get, dear students? So 2 into differentiate with respect to x, 2 into x plus 1, here 2 into y minus 2 into dy dx, and that is equal to right hand side is 0. So from here what we get, dear students, so this implies y minus 2 into dy dx is equal to minus x plus 1. So from here what you can write, dear students, that dy dx is equal to 1 plus x divided by 2 minus y. And dear students, this is the corresponding differential equation whose particular solution is this one. Later, when you will start learning that how to solve a differential equation, which will start in the next session, there you will see that this particular solution, this is a particular solution to this differential equation. And as you remember, in the earlier classes I mentioned, what is a solution to a differential equation? A solution to a differential equation represents a family of curves. So if you look into this, this is a circle. Now if you look into this, we can say, if you look into this particular statement here, particular mathematical equation, you see this is a circle having radius at the point minus 1 comma 2 and with radius 1 unit. Now when it is a family of circles, okay, you will see that the radius is different. Okay, here it is radius is 1 unit, but there will be the radius will be different, but it will have the same center, that is minus 1 comma 2. So as if something like this, if we give a a drawing here, so this is origin, this is positive direction of x-axis, this is negative direction of y-axis, This is positive direction of y-axis and this is negative direction of y-axis. So minus 1 comma 2 will be a point somewhere like this. This is the center. Now what will be the family of circles, So family of circles will be something like this. One circle will be like this. One circle will be like this. In that way we will get the family of circles. Okay. Now out of those family of circles, this is specific only one such solution. Okay, that is why it is not it is known as particular solution and it is not having any arbitrary constant. Now dear students, we are going to see that how to form a differential equation whose general solution is given. So now dear students, so let's form a general solution of a circle, but it is going to have arbitrary constant. Okay, what kind of it is? So let me write it down. So let us write this general solution. X square plus y square is equal to r square. So this is the equation of a circle having center at the origin and having radius r unit. Now you can vary r, and as you vary r you will get different circles, all having the same center, that is at the origin, but radius different. So that becomes a family of circles having center at the origin. So if we give a pictorial description, so this is the positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction, this is origin. So one circle is this, another circle is this, another circle is this, something like this. Okay, in that way it will proceed. What we are going to do? We are going to form a differential equation whose general solution is this. This is the general solution. So perform that, how to find the differential equation whose general solution is given, we have only one task in our hand. What is that? That is that removal of the arbitrary constant. If you see in this equation, what is the arbitrary constant? R. So our task is to remove that r. And how we are going to remove it? By differentiating both the sides of this equation with respect to x. Now dear students, if we differentiate this particular equation with respect to x, what we are going to get? 2x plus 2y dy dx is equal to 0, because r is an arbitrary constant, no? So its differentiation will be 0. So from here what we get, dear students? We get x plus y dy dx means what? Y dash, that is equal to 0. So this is the differential equation representing this general solution. Or I can say that the family of curves represented by the equation x square plus y square equal to r square, where r is an arbitrary constant, belongs to the set of real number, is represented by the differential equation x plus y into y dash equal to 0. Y dash means dy dx. Got it? Now let's take another example. After looking into a couple of examples, then you will find the procedure. What procedure you should follow to form a differential equation whose general solution is given. So now the next equation what I am going to write is that something like this: y equal to mx plus c. All of you are aware what that y equal to mx plus c represents. Okay, this is the general equation of a straight line having slope m and y-intercept c units. Okay, so if I draw the straight line, so how it looks like, let me show you. So what is our equation? Y equal to mx plus c. What is m? M is the slope of that straight line. This represents a straight line having slope m and y-intercept c units. That means what? That means if we draw a straight line something like this, okay, so this is the straight line representing this equation y equal to mx plus c. Okay, so if this angle is theta, means the straight line makes an angle theta with the positive direction of x-axis, and if this intercept, so this is origin, if we say this point is A, if OA is c units, then we can say the equation of the straight line is y equal to mx plus c. Or the other hand, if the equation of the straight line is y equal to mx plus c, we can say that if that straight line makes an angle theta with the positive direction of the x-axis, then m is equal to tan theta. And what is c? c is the y-intercept made by the straight line. That means that if the straight line, intersecting the y-axis at the point A, then this length OA is equal to c. Now dear students, if you see, there are two parameters here. One parameter is m, another parameter is c, means arbitrary constant. Both m and c belongs to the set of real numbers, correct? M and C belongs to the set of real numbers. That means what? You can vary the value of M and C and you will get different straight lines, correct? For example, if you take that value, if I use a different color, okay, if I use the value of M equal to 1, that means theta is 45 degree and C is equal to 0. That means y-intercept 0 and that straight line making an angle 45 degree with the positive direction of x-axis. That is why tan 40 is 1, means slope is 1. So what will be that straight line? The straight line will be something like this, representing y equal to mx, correct? Means y equal to mx means here only can write y equal to x. Similarly, if we write the value of m is equal to minus 1 and c is equal to 1. That means what? That it is making an angle of 135 degree with the positive direction of x-axis. That means it is an obtuse angle and y-intercept is 1 unit. That means a straight line will be something like this, correct? Where this length is 1 unit and this angle is, if we take whatever the angle, that tan of that angle will be minus 1. So if you see this straight line, it will be y equal to minus x plus 1, or we can write x plus y equal to 1. So as you see dear students, as we vary the value of m and c, we will get different straight lines. That means it is a family of straight lines. On the other way, what we can say, y equal to mx plus c represents a family of straight lines. Okay, now what we are going to do, we are going to form the differential equation represented by this family of straight lines. How to do? First and foremost, as I said few minutes back in the previous example, our task is to remove these arbitrary constants. And how to remove that arbitrary constant? By differentiation. So if we differentiate both sides of this equation with respect to x, what we are going to get dear students? So from here we get dy dx is equal to m plus 0, because differentiation of c, that is an arbitrary constant with respect to x, is 0. So y equal to m. So we see still there is an arbitrary constant. Out of two arbitrary constant, one differentiation removed one, but still one is there. So what you should do? We should again differentiate this equation with respect to x. That means it is d2y dx2 is equal to 0. So this equation, this differential equation represents the family of straight line y equal to mx plus c. Okay. If you recall dear students, the previous example where we discussed about the circle x square plus y square equal to r square, there we formed a differential equation. We can quickly form this one, okay? That x square plus y square equal to r square, the previous example. So from here we differentiated both sides with respect to x dy dx is equal to 0. So from here what we get, x plus y dy dx is equal to 0. So why I write this differential equation once more, what I have already discussed few minutes back, to show you something. If you see in this particular general solution, that is x square plus y square equal to r square, how many arbitrary constants are there? 1, that is r. And corresponding differential equation, what is the order? 1 dy dx. Now look into this equation, the family of straight lines. Y equal to mx plus c. How many arbitrary constants are there? 2, m and c. And its corresponding differential equation is having order 2. So what we can say is that, and in that way, if you see if there are 3 arbitrary constants in a general solution, the corresponding differential equation will have order 3. So what we have learned, that in a general solution of a differential equation, the number of arbitrary constants will tell that the corresponding differential equation will have what order. The number of arbitrary constants is equal to the order of the corresponding differential equation. Okay. So now, dear students, what we are going to do, we are going to learn the procedure. Whatever I have discussed so far is by means of example, but exactly what procedure you should follow to form a differential equation that represents a family of curves. Okay. So here it is, here the procedure. And when I am discussing this procedure, I will also take one example, one representative example I will take, so that you can resemble exactly how this procedure is actually going to be followed. Okay. The first one, dear students, that what I am going to take this, suppose you have a general solution something like this. The curve is f1. It will contains what? It will contains an independent variable x, a dependent variable y, correct, and an arbitrary constant a, correct. So this is equal to 0. Clear? Now what we are going to do, so suppose we give this equation as equation 1, that is given. That is the general solution of a differential equation, and we are going to now learn the steps to be followed to find that differential equation. Now after that, what we will do, we will make a differentiation of both sides with respect to the independent variable x. Why so? Because as I said when I was discussing the examples, that our task is to remove this arbitrary constant. Here a is the arbitrary constant, and our task is to remove that arbitrary constant. And how to do this thing? So what we are going to do, we are going to differentiate with respect to x, the independent variable. Now if we differentiate, we will get a function like g, which will have the independent variable x, the dependent variable y, and y dash, the differentiation of the dependent variable with respect to the independent variable x. That means dy dx in simple terms. And we get an arbitrary constant. It may or may not have the arbitrary constant. So for the sake of simplicity, I am writing the arbitrary constant and this one. After that, what we will do, we will solve these two equations, equation 1 and equation 2, to get what? To get an equation something like this, f, it will contain the independent variable x, the dependent variable y, and the differentiation of the dependent variable y with respect to the independent variable x. That means it is a function containing x, y, and y dash, that is dy dx, that is equal to 0. And this is the differential equation whose general solution is the equation 1. Correct? Sure. This we can say the equation 3 represents the differential equation for which for the equation whose general solution is the equation 1. Let us see by means of an example, because this is too theoretical, okay, but how we can represent by means of an example. So corresponding to this equation, whose general solution is this f1 xy comma a, x comma y comma a. So let's take an equation is that y equal to ax, correct? So this represents this equation. After that, what we will do? We are going to make a differentiation of both sides. So if we make a differentiation of both sides, what we are going to get? Dy dx is equal to a, correct? So as if this is equation 1 and as if this is equation 2, correct? That is g x y y dash comma a, it is like this, dy dx equal to a, correct? Now as I said that we need to remove that arbitrary constant by solving equation 1 and 2, and that's what we are going to do. So from this equation 2, what we can write? This implies dy dx is equal to, what is a? A is nothing but y by x. From equation 1 we can say this thing, right? Y equal to ax, so a equal to y by x. So instead of a we can write y by x. So what we can write, dear students? So we can write that x into dy dx is equal to y is the differential equation represented by y equal to ax, or we can write this in the same thing, we can write x into y dash is equal to y. This is as if equation number 3, correct? Understood? Now in this equation what we see, dear students, there is one arbitrary constant. That is why the corresponding differential equation is having order 1. Now we are going to see that if the general solution means the family of curves is having two arbitrary constants, how to find the corresponding differential equation. How means the procedure. Here we are learning the procedure, okay? So let me write it down here. So suppose we have a curve something like this f2. It contains x, the independent variable, y, the dependent variable dependent on x, and two arbitrary constants a and b equal to 0. And this we are giving an equation 1. What is the first step? First step is that to differentiate both sides of this equation. What we are going to get? We are going to get a curve called g. It will contain x, independent variable, y, the dependent variable dependent on x, then y dash, the differentiation of the dependent variable y with respect to the independent variable x, and it may have the arbitrary constant a and b. Why I am saying may have? Because due to differentiation some of the arbitrary constant may actually get removed. But that depends on what type of equation it is. This is a generic equation, no? So that we cannot confidently say which will get removed or whether it will get removed at all or not. And same is true for x and y. Some may get removed, may not removed. Then what we will do, so suppose we give this equation number 2. Then what we will do, dear students? Again we will differentiate once more. Why we will again differentiate? Because there are two arbitrary constants. So that's why we need to differentiate once more. That means we need to find a second order differentiation. So if we differentiate, suppose we get a function called h. So what it will contain? It may contain x, y, y dash, then y double dash. That means differentiation of y with respect to x 2 times, second order differentiation. And it may have a and b that is equal to 0. And we give this equation as equation 3. Then, dear students, our task is to solve this equation 1, equation 2 and equation 3 to remove those two arbitrary constants a and b. And as a result, what will land up? We will land up with the equation something like this: f containing x, the independent variable, y, the dependent variable dependent on x, y dash, that is dy dx, and y double dash, that is d2y dx2 is equal to 0. And as you see, this particular equation is not having any arbitrary constants a or b. Okay. So this is the differential equation. Equation 4 is the differential equation represented by this general solution. Correct? Now let's take an example, because again this is a very theoretical. So if we take an example, we can make one correspondence to understand this procedure very well. So let's take an equation something like this: y equal to a sine x plus b. Okay. So now this is having two arbitrary constants like this. So as if this is equation number 1. So what is our first step, dear students? To differentiate this equation, equation 1, in both sides with respect to x, the independent variables. So from here, if we differentiate, what we get? Dy dx is equal to a cos x plus b. Okay. So this is equation number 2. As if this g is something like this, and this equation is something like this. Correct? You make the 1-1 correspondence. Now what we will do? We need to achieve to h. That means we should differentiate once more. This equation, this general solution is having two arbitrary constants, so we need to have second order differentiation. So what we will get? So this implies, if we differentiate once more the both sides of the equation 2 with respect to x, we are going to get d2y dx2 is equal to minus a sine x plus b. This is as if, like this. Now what is our task? Our task is to remove these arbitrary constants a and b by means of these three equations. So how to do this thing? In this case it is pretty simple, because this a sine x plus b is nothing but y. So from here what you can write? d2y dx2 is equal to minus y. So we can write d2y dx2 plus y is equal to 0. So as you see, dear students, this particular equation, you can give the name as equation 4. It is actually 1-1 corresponding to this one. So this equation d2y dx2 plus y equal to 0 is the differential equation represented by the family of curves y equal to a sine x plus b. Correct? So dear students, so far we have learned the procedure and the representative examples. So what is the most important point? I said earlier, but I repeat once more. In that given general solution or the given family of curves, the number of arbitrary constants will be equal to the order of the corresponding differential equation. Now dear students, we are going to take some examples and solve one by one. Okay, so you also do along with me. So the first question, I'm going to write it here. You also please do along with me. That is important. Then what will happen, dear students, if you do along with me, you will see that your preparation is complete. You don't need to again spend time. Whatever the time you are spending in watching this video, and with this time only your learning will be complete. And after that, what you need to do? After that, you need to log into the online test platform at konarclasses.com and appear for DPP, unit test, practice test, module test, mock test. So that more practice makes you perfect. So the first question I am going to give it here, dear students. Okay, so let me take it from the notebook. The question here is that, let me take in the black color. Okay. So the first question here, dear students, is that form the differential equation. Form the differential equation. I am writing DE, differential equation. Okay. Representing the family of curves. Representing the family of curves, the family of curves y equal to mx, where m is arbitrary constant, where m is arbitrary constant. That means m belongs to the set of real numbers. As you vary m, you will get different curves, and all those will be the particular solution to the differential equation which you are going to find. Now let us understand geometrically what is this actually particular equation, y equal to mx. All of you are aware from the straight line, y equal to mx is nothing but a straight line passing through the origin and having slope m. So if we represent that, so what it will be? It will be something like this. This is origin. So a straight line passing through the origin. Okay, it can be something like this. All this, whatever I am drawing in the black color, are passing through origin. So this is, it could be this. All these are straight line. Whatever I have drawn in the black color is represented by y equal to mx. Now what we are going to form? We are going to form the differential equation whose general solution is y equal to mx, or which is represented by the family of curve y equal to mx. Very simple. We need to eradicate, remove this m. How to do this thing? Differentiation. So from this equation y equal to mx, what we will do, dear students? So we are going to differentiate. What is this? If we differentiate both sides with respect to x, we will get dy dx is equal to m. Now what is the value of m? M equal to y by x. So from here we get dy dx is equal to y by x. Correct? So you can either leave it here or you can write x into dy dx is equal to y. And this is the differential equation represented by the family of curves y equal to mx. Correct? Let's proceed to the next question. So, the next question I am going to write it down. So, let me take this question from my notebook. Okay. The question is, form the differential equation. Form the differential equation, DE I am writing differential equation, representing the family of ellipses, representing the family of ellipses having foci on x-axis, having foci on x-axis and center at the origin, and center at the origin. Okay, so this is an English statement, and from there we need to give a visual representation of what will be the ellipses will looks like. So if we draw the coordinate axis first, so it is given that the foci is on the x-axis and center is at the center of the ellipse is at the origin. So ellipse will be looks like something like this. That is one ellipse. Now the family of ellipses My drawing is not that great, but you understood that exactly what is meant by that. Okay, so these are the family of ellipses. Okay, what is the equation? If you recall our classes on ellipse, its equation is x square by a square plus y square by b square equal to 1. Correct? X square by a square plus y square by b square is equal to 1. What is a, b? And these are not the topic of the discussion in this class. You can follow my classes on ellipses. You will get details about it. What is represented by a, b, eccentricity, etc. Now, what is our task? Our task is to form the differential equation whose general solution is this. Or we need to form the differential equation which is represented by the family of curves. Now, this particular family of curves is having two arbitrary constants a and b. So, in our differential equation, obviously it should have order 2 because it will be equal to the number of arbitrary constants. How we are going to achieve? Let's see. First, what we will do, dear students, we will differentiate both sides of this given family of curves or given equation with respect to x. So, what we will get here, dear students? So, this implies 2x by a square plus 2y by b square into dy dx is equal to 0. Correct? So, this implies what, dear students? So, from here what you can write, this implies that y by b square into dy dx is equal to minus x by a square. Or you can write, this implies y by x into dy dx is equal to minus b square by a square. Correct? So, what we are going to do, dear students? So, our task is to remove a and b. So, if we look into this and let's take it here and proceed. So, now what we are going to do? We are going to differentiate again. So, let us differentiate in the left hand side. Okay. So, that is in the product rule, u into v rule. That means if we differentiate once more, what we are going to get? Y by x into d2y dx2 d2y dx2 plus dy dx plus dy dx into ddx of y by x into ddx of y by x, and right hand side will be 0 because minus b square by a square is a constant. So, we can write this is equal to 0. So, this implies y by x into d2y, let me write x properly, y by x into d2y dx2 plus dy dx into ddx of y by x, that means ddx of u by v, that is x square x into dy dx minus y into ddx of x, that is equal to 1, that is equal to 0. So, from here what we get, dear students? So, if we multiply both sides by x square, what we are going to get? So, this we can give a bracket here. Let's multiply both sides of the equation by x square. So, what we are going to get? Xy into d2y dx2 plus x into dy dx whole square, okay, minus y into dy dx is equal to 0. Correct? So, as you see, this represents the differential equation. So, this one xy into d2y dx2 plus x into dy dx whole square minus y into dy dx represents the differential equation for this family of curves x square by a square plus y square by b square equal to 1. So what you need to do, dear students, by looking into the problem statement, this type of question comes in the examination. By looking into the problem statement, first you need to form that equation, which is the family of curves, or which is the general solution of the corresponding differential equation. And after that, the procedure what we learned to form the differential equation. Differentiate, remove the arbitrary constant. Number of arbitrary constants is equal to the order of the corresponding differential equation. Straightforward process. It's not complex, but understanding the process is, procedure is important. Let us proceed to the next question, dear students. Okay. So let me take the question from my notebook, okay? So the question here is, form the differential equation of the family of circles. Form the differential equation of the family of circles of the family of circles touching the x-axis at origin. Touching the x-axis at origin. So dear students, first and foremost, as I said in the previous case also, we need to first represent that what type of curves it will be. It is a circle, but the circle is something like this, that touching the x-axis at the origin. So how it will looks like? So let us draw the coordinate axis first. Touching the x-axis at the origin. That means what? A circle something like this, a circle something like this, a circle something like this, okay, a circle something like this. If you look into all these circles, what I draw in the black color, that is all having the property as explained in this question. Family of circles touching the x-axis. It is all touching the x-axis at the origin. That means what, dear students? That circle is passing through the origin, number one. And all these circles is having the center on the y-axis. For example, this particular circle, small circle, having the center here. This circle is having the center here. This circle is having the center here. This big circle having the center here. All this, as you see the point, I drawn in the black color, these are the centers of these circles. And what is the centers of this circle? That is on the y-axis. Any point on the y-axis having x coordinate 0. So that means if we take a arbitrary circle, its coordinates should be 0, a, where a is the radius of the circle. Correct or not? This is a. So what we can do, dear students, from this information, we can write down the equation of the circle by applying our concepts, what we have learned in the class 11, that what is the equation of a circle having center at the point 0, a and having radius a units. What is that? X minus 0 whole square, correct? Plus y minus a whole square is equal to a square, correct? Again, if you want to know the details about it, please follow my lecture on circles. Now what we are going to do, our task is to eradicate or remove the arbitrary constant a. Let us simplify. This implies what? This implies it is x square plus y square minus 2 into a into y plus a square is equal to a square. Correct? So this implies x square plus y square, okay, minus 2ay is equal to 0 because a square got cancelled. After that, what we will do, dear students, we need to differentiate with respect to x. Why so? Because we need to remove the arbitrary constant or eliminate the arbitrary constant or eradicate the arbitrary constant, whatever the word you can use. If we differentiate both sides of the equation with respect to x, we get 2x plus 2y dy dx minus 2a into dy dx is equal to 0. Correct? Here, from here, what you can write? X plus y into dy dx minus a into dy dx is equal to 0. What we can proceed in this part is that x plus y into dy dx is equal to a dy dx. A dy dx. What? So this implies x plus y dy dx is equal to a. A is equal to x square plus y square by 2a. X square plus y square divided by 2y. X square plus y square by 2y into dy dx. So from here, if we simplify, what we get, dear students? X square plus y square divided by 2y minus y into dy dx is equal to x. So that implies x square plus y square minus 2y square means x square minus y square. So from here, what we get? X square minus y square divided by 2y into dy dx is equal to x. So from here, what we get? Dy dx is equal to 2xy divided by x square minus y square. So this differential equation represents the family of curves, this one, which is actually mentioned in this problem statement. Quick information, we already discussed all these things. This equation is having only one arbitrary constant. That is why the corresponding differential equation having order 1. The last question for today's session, okay, and let's solve together. So as you see, by looking into the problem statement, that first you need to give a visual representation that exactly what type of curve it is, find the different parameters. After that, write down the equation. After that, follow the procedure as we discussed to eliminate the arbitrary constants. So the last question in this session, dear students, okay? So let me write it down. The question here is, form the differential equation, representing the family of parabolas, representing the family of parabolas, parabolas having vertex at the origin, and axis along positive direction of x-axis. Positive direction of x-axis. Okay. First, what you should do? First, we should give a visual representation. So it is a family of parabolas. So first, let's see that how it will looks like. For that, first let's draw the coordinate axis. X, x dash, y, y dash, origin. Parabola, family of parabolas having vertex at origin means all these parabolas is having the vertex at the origin. Here vertex will be here, and the axis means axis of the parabola along positive direction of x-axis. That means what? A parabola will be something, looks like something like this, correct? But family of parabolas, that means one parabola will be something like this, one parabola will be something like this. I am not that great in drawing, but I hope you understood what I am meaning by this thing. One parabola is something like this. If you see all these parabolas, what I have drawn in the black color, are having the same properties as mentioned in the problem statement. All are having vertex at the origin, and all are having the axis as the positive direction of x-axis. That is why it is known as a family. You know the family, when it belongs to a particular family, what it means? We carry the same surname, correct? So similarly here, and this is the family of parabolas. Now what is the equation of such parabolas? So let's see. What is that? If you recall our class 11 topics, it is y square equal to 4ax, correct? What is a? For that you need to refer to my lecture on parabolas. What is our task? Our task is to remove, eliminate, eradicate this arbitrary constant a. Whatever the problem statement it is given, so this is actually mathematically represented by this equation. So how to eliminate the arbitrary constant? Differentiation. Not only that, if we differentiate, and once we get the differential equation, one thing we are sure, without forming the differential equation, that differential equation is going to have order 1. Why? Because the corresponding equation whose general solution is given here having one arbitrary constant. That is why the differential equation, what we are going to derive now in another few minutes, is going to have order 1. How to do this thing? Let us differentiate with respect to x. So 2y dy dx is equal to 4a. Now what is the value of 4a? The value of 4a is equal to y square by x. So from here what we can write? 2y dy dx is equal to y square by x. So from here what we can write, dear students? Y square minus 2xy into dy dx is equal to 0. So as you see, this is the differential equation represented by the family of curves y square equal to 4ax, which is represented by the problem statement here. So with this note, let me conclude the class here. In the next session, we are going to learn how to solve differential equation of first order and first degree. Till that happen, what is your task? Your task is to log into the online test platform at konarclasses.com and appear for DPP's first daily practice problem, followed by practice test, that is we call as PT, followed by UT, that is unit test, followed by MDT, that is module test, and finally by mock test. Thank you very much. Bye bye.